Okay, this chapter is the digestive system. The first item is general anatomy and digestive processes. If we scroll down, we can see here the functions of the digestive system: ingestion, digestion, absorption, compaction, and defecation. Okay, first step in digestion most of the time is mechanical digestion and chemical digestion. There are the two main kinds of digestion. For example, mechanical digestion is done with your teeth, and chemical digestion is done with the acid, for example, that you have in your stomach. General anatomy, well, we can scroll down right here and we can see the digestive system is basically composition of multiple different organs, and we have in here one of them is the mouth. Then we have right here the esophagus, stomach, intestines. In addition to that, we have accessory organs to the digestive system, in which you find the salivary glands here, liver, and pancreas. Okay, very important to know that those are accessory organs to the digestive system. If we scroll down, regardless of the area of the digestive system that you are working on, that you are looking at, you're going to see the digestive system has 4 layers: mucosa, submucosa, muscularis, and serosa. We keep scrolling down. You can see that again: mucosa, submucosa, serosa. And the last one that we're going to have right here, muscularis. I forgot that. Mucosa, submucosa, muscularis, and serosa. Okay. So if we keep scrolling down, we have in there mucosa, muscularis, serosa. Okay, and we're going to have obviously a few set of nerves, and these nerves are going to help us move the intestines, the stomach, and all the other organs that need to be moved in the digestive system. And these are different plexuses, different sets of neurons that are going to move that. One of them is going to be the main nerve plexus, and the other one is the hour back plexus. Okay, those are main sets of nerves. Autonomic. Go below that, we're going to see here that we have the peritoneum. Peritoneum refers to the membranes that we have in the digestive system, in peritoneum being one of them. Membranes that are going to cover many of the organs that we have in the digestive system. They are going to attach to them, allowing them to move, but with certain restrictions. So they can perform their job, but they don't move around the abdominal area and ending up in just one area of your digestive system. For example, all the intestines can move, but they don't end right here as a big mass of intestines in here. So that's the function of the membranes. Again, one of the membranes that we have is a peritoneum that is going to cover the back part of the abdomen, and the front is going to go around many organs that we have right here. Most of the organs that are found inside the peritoneum are called intraperitoneal. Some other ones, or some other organs such as the kidneys, are not covered by the peritoneum, therefore they are called retroperitoneal organs. Also, we have 2 very important serous membranes, mucous membranes, and these ones are going to be the omentum, greater omentum, lesser omentum. The greater omentum is in front of the intestines, behind the abdominal wall. It contains a lot of fat, as you can see here. You have the lesser omentum that communicates the stomach with the liver. In the middle, this area right here, this membrane, it's called the mesenteries. Again, this maintains the intestines in place, so they have certain movement, but they don't move completely away from their initial location. And not only that, it also allows the passage of the blood vessels to provide blood to the intestines. These blood vessels are the mesenteries. Okay, so let's keep going. Scroll down. Oh, right here, if I just noticed, mesocolon is the mesenteries, but are going to the mesenteries that are attached to the colon. That's the mesocolon. Keep scrolling down, and as I said, some organs are intraperitoneal, other ones retroperitoneal. Regulation of the digestive tract. This is done with nerves, enteric nerves and vagal nerves, and these ones are going to produce reflex that will allow you to move your intestines. In the case of, for example, peristalsis. And that's it for this chapter. Or I should say the topic in this chapter. The next topic is the mouth through the esophagus. in your digestive system. So in the mouth, you have different structures in there, such as your uvula, your tongue, your palate. Okay, so we're going to be looking at those things right now. So we scroll down, the cheek and the lips. Basically, the main job is to move the food close to the teeth so we can actually chew them. And that's how we start chewing. And then the tongue is also very important. Is mainly form of muscles, and it has intrinsic muscles and extrinsic muscles. The intrinsic muscles are the ones that are going to form the tongue. If you look at the tongue, the surface of the tongue has a lot of papillae. Inside the papillae, you have the taste buds. The two is basically divided in three pieces: the anterior 2/3 and the posterior 1/3, which is going to be the root. And obviously, it has different functions, such as taste. It allows us to talk. Okay, very important. And like I said, we have intrinsic muscles and extrinsic muscles. Don't forget that the tongue is basically muscle. The palate, we have two parts in it. You have the hard bony plate, which is made of bone, and the anterior part is the soft palate, which is mainly skeletal muscle. The palate separates the nasal cavity from your mouth, so it allows us to chew and at the same time breathe. Next item in here is the teeth. That's the first part or the initial point of digestion, more specifically mechanical digestion. And this is not a dentistry class, so I'm not going to talk much about the teeth. However, a couple of things that you need to know is that the teeth has at the top the crown, the middle is the neck, at the bottom is the root. As long as you know those three things for the teeth, I will be convinced that you know that item. So we keep scrolling down. Again, more and more teeth. Just teeth continue. Mastication. Mastication is basically digestion. And as I said, the first part of digestion starts with your teeth. Then we have saliva and salivary glands. The beginning of the formation of saliva is just a filtration of ions and water from the capillaries that you have in your mouth. So looking at this with a little bit more specificity, we can see that the pH of your saliva is approximately neutral, and it contains lots of water, kind of like 99% of water. In addition to that, what else we have? Mucus, electrolytes, lysosome, which is an enzyme that destroys bacteria, antibodies such as immunoglobulin A, salivary amylase that is going to help us with the digestion of carbohydrates. And this is part of chemical digestion, not mechanical digestion. As I said before, mechanical digestion is with your teeth. Salivary amylase is going to give you the chemical digestion. Lingual lipase is for fat, but as you can see here, again, so the begins fat digestion in the mouth, but mainly after the food is swallowed. Okay, it doesn't have a lot of functions, to tell you the truth. The lipase, the most important one in digestion, is going to be amylase, which is digestion of carbohydrates. So those are the characteristics of saliva. Which ones are the salivary glands? We have two main kinds, intrinsic and extrinsic. Intrinsics are numerous salivary glands that we have all over our mouth, very, very tiny, and they secrete just small amounts, basically 24/7, but just small, very, very, very small amounts of saliva. Extrinsic salivary glands, we have three. They are going to be parotid, sublingual, as you can see right here, parotid, sublingual, and submandibular. Those are the extrinsic ones, and those are the biggest salivary glands that we have. Here you have composition of a gland. I'm not going to talk about it. That's anatomy 1. Right here you have the three kinds, as I said: parotid glands, sublingual, and submandibular. Okay, salivation. The extrinsic glands, again, are the ones that produce most of the saliva. They're going to produce approximately 1 to 1.5 liters of saliva throughout the day. I already explained that it's basically water and ions that are going to come out of the capillaries you have in your mouth. The pharynx is the behind your mouth is oropharynx, and we've seen this in the respiratory system. After the pharynx, we are going to continue with the esophagus, which is the continuation of the pharynx. The esophagus has a set of muscles, very important because they are going to produce peristalsis at the level of the esophagus in order to push the food down into your stomach. The bottom of the esophagus, you're going to have an orifice called the cardiac orifice, and you're going to have a sphincter that will stop the contents from your stomach to going back up. And that is going to be the lower esophageal sphincter. We keep scrolling down. Swallowing, that initiates in your mouth and is pushed by your tongue. It uses several different set of muscles, therefore there is the use of several different types of cranial nerves. And as you can see here, the ones that are involved are going to be cranial nerve number 5, 7, 9, and 12. See here in green how the food starts going down from your mouth. That's the oral phase. Goes into your pharynx, pharyngeal phase, and then goes down into your stomach through the esophageal phase. So you keep scrolling down. You have in there the same things that I just mentioned, and then that's it for this item. The next item in this chapter is the stomach. We scroll down, and let's take a look at the anatomy of the stomach. So might as well use this figure. The top part of your stomach is the fundus. The area around the connection between the esophagus and the stomach is the cardiac region. The body is the middle. Lesser curvature, greater curvature. This is the pyloric region where you have the pyloric sphincter right here. Inside the stomach you have these elevations and grooves. They are called rugae. Let's keep scrolling down. After the stomach, obviously, you have the that's where the small intestine starts. The first part of the small intestine, as you can see here, is the duodenum. Let's keep scrolling down. Have the stomach in there again. Greater and lesser curvature. Innervation is given to you by the autonomic nervous system, parasympathetic and sympathetic, especially the parasympathetic is by the vagus nerve, and the celiac ganglia for the sympathetic. If you cut the stomach and you look at the cells that you find in the stomach, you're going to see different kinds. You're going to see first that you have some grooves. They are going to be called the gastric pits. Inside these grooves, you're going to have these cells. What cells you have in the gastric pits? Mucous neck cell, parietal cells, mucous cells, chief cells, and G cells. Parietal cells are the ones that produce, for example, the acid that we have in the stomach. Let's take a look at these cells. Keep scrolling down. Then you have the cells in there again. There's a table where we can see this a little bit better. So we go down. Gastric secretions, we are going to have acid in the stomach, approximately 2 to 3 liters of acid. Hydrochloric acid. Before we find the cells, we can see how the acid is formed. You have carbon dioxide in your blood. Carbon dioxide goes into the parietal cells. They mix with water, and you form carbonic acid. Similar formula to the one we've seen many times during the respiratory system. After you have carbonic acid, the carbonic acid is going to split into bicarbonate and hydrogen. Bicarbonate goes back into your blood because it gets exchanged with chloride, with a chloride shift. Bicarbonate this way, chloride gets pumped the other way around. The hydrogen, it gets pumped into the lumen of the gastric gland using the hydrogen potassium pump. You put potassium inside the cell and you pump the hydrogen outside. Now you have the hydrogen and the chloride in order to form the hydrochloric acid in your stomach. So let's keep scrolling down. Right here you have the formula that you've seen many times before. A hydrogen potassium pump and the chloride shift. You should be familiar with these terms. Let's keep scrolling down. Functions that you have with the acid, very important. It activates pepsin. We're going to see that later on. It breaks